Good day, 9th graders! Muli, ako si Sir Jonathan Campilia at narito ako upang kayo ay gabayan para sa ikalawang bahagi ng ating talakayan para sa linggong ito. Anumang katanungan o karagdagang paglilinaw pagkatapos ng ating talakayan ay maaari ninyong ikonsulta sa inyong mga guro sa Mathematics 9. For this video, pag-uusapan natin ng tungkol sa combined variation. At the end of this video, we shall be able to illustrate situations that involve combined variation. But before we proceed, importanteng malaman muna natin ang kahulugan ng combined variation. Combined variation describes a situation where a variable depends on two or more other variables and varies directly with some of them and varies inversely with others when the rest of the variables are held constant. If you can observe, makikita sa definition ang salitang varies directly at varies inversely. Kaya nga nasabing combined variation dahil it is a combination of direct and inverse variation. So for combined variation, we will encounter the phrase z varies directly as x and inversely as y. Take note that variable z represents the dependent variable, while x and y represent independent variables. This could be translated as z equals k times x all over y, where k is the constant of variation. The variable after the phrase varies directly is located at the numerator of the variation equation. In this case, we have the variable x, while the variable after the word inversely is located at the denominator of our variation equation. In this case, we have variable y. This discussion will help you to answer Activity 1 entitled Let's Bolt In. For this activity, we are going to translate situations into variation equation. Let's begin by answering the following examples. For example number 1, the volume of gas V varies directly as the temperature T and inversely as the pressure P. To translate this situation, kailangan muna nating i-determine ang dependent at independent variables. For this case, variable V is the dependent variable, while T and P are the independent variables. With this, we could translate this situation as V is equal to K times T all over P. Tulad ng sinabi ko kanina, the variable after the phrase varies directly is located at the numerator of the variation equation, while the variable after the word inversely is located at the denominator of our variation equation. So as simple as that. For our next example, the force of attraction F of a body varies directly as its mass m and inversely as the square of the distance d from the body. So uulitin lang natin. We have to determine first the dependent and independent variables in this situation before we translate this into variation equation. Variable f represents the dependent variable, while variable m and d represent independent variables. So we could translate this situation now as f is equal to k times variable m all over the variable d squared. Why d squared? It is because of the word or the phrase square of the distance. That is why we have to square d. Okay, for our third example, y is directly proportional to x and z and inversely proportional to the cube of w. So let's determine the dependent and independent variables. Y is known as the dependent variable, and we have x, z, and w are the independent variables. So if we translate this into variation equation, we will have y is equal to k times x times z, since y is directly proportional to these two variables, all over w cubed. This is because of the word cube of w. So that's how to translate situations into variation equation using combined variation. So that's all for this video. Thank you for watching and stay tuned for the next virtual instruction.